Case closed. That's how this should feel, because the data has been sitting there for over a decade, and yet gym forums are still arguing about it like it's an open question. Here's the defendant everyone assumes is guilty. The 30-minute anabolic window. The idea that if you don't get a shake in your hand within half an hour of your last rep, you've torched the entire workout. No gains. Wasted session. We pulled 12-plus peer-reviewed trials and meta-analyses, ran them through this ledger, and we're handing down 3 verdicts today. Exact numbers. No more guessing about timing, dosage, or whether your kidneys are about to file a complaint. First up, the window itself. The old belief goes like this. You train, and then a clock starts ticking. 30 minutes, maybe 60 if you're generous. Miss that clock, and the muscle protein synthesis opportunity closes. You just wasted an hour in the gym because you didn't have a shaker bottle in your gym bag. Schoenfeld and his team tested this back in 2013, and the finding held up under scrutiny for years. Once you control for total daily protein intake, the timing advantage mostly disappears. The window isn't 30 minutes. It's hours wide. Some readings of that data put the practical window at 4 to 6 hours around training, depending on what and how much you ate beforehand. And this isn't old news getting recycled. Casuso and Goossens ran a head-to-head timing comparison in 2025, comparing protein taken 15 minutes before exercise all the way out to 2 hours after. Lean body mass? No meaningful difference across that entire range. The certainty on that finding was rated low, sure, but it points the same direction every other study points. Now here's the nuance, because the biology isn't completely silent on this. G and his colleagues published acute signaling data in 2025 showing that whey protein taken right after exercise does bump fractional synthetic rate by something like 1.3 to 1.6 times. Signaling peaks around 1 to 2 hours post-workout, then fades out by hour 4 or 5. So something real is happening at the cellular level. But a blip in acute signaling is not the same thing as a difference in muscle built over months. That's the part people get twisted on. You can have a bigger spike on paper and still end up in the exact same place 12 weeks later. Because the body doesn't care about your Tuesday afternoon FSR reading, it cares about the sum of everything you fed it that week. The ruling. Total daily protein intake explains almost all the variance in hypertrophy outcomes. Timing, in the context of a normal training day with regular meals, is a rounding error. Not zero, just small enough that obsessing over it is missing the actual lever. If timing isn't the lever, what is? That's where this gets specific, because the answer isn't eat more protein in some vague sense. It's an exact number, and it changes depending on how old you are. Start with the daily number, because everything else builds on top of it. For anyone doing resistance training and trying to build or hold onto muscle, the target is 1.6 to 2.2 grams per kilogram of body weight per day. Below that range, you're leaving gains on the table. Above it, the curve flattens out fast. You can push past 2.2 grams per kilogram if you want, but you're mostly just paying for expensive urine at that point, not building extra tissue. Now, split that daily number into meals, and this is where it gets interesting, because the per meal target isn't the same for everybody. For younger adults, the plateau sits around 20 to 25 grams of high-quality protein per meal, which works out to roughly 0.24 to 0.31 grams per kilogram. Wittard and his team tested this directly back in 2013. They gave young men 20 grams of whey after resistance training, then compared it against 40 grams. Muscle protein synthesis with the 40-gram dose? No better than the 20-gram dose. All that extra protein did was spike amino acid oxidation, meaning the body just burned the excess for fuel or converted it to urea instead of using it to build muscle. You paid for 40 grams and got the benefit of 20. Older adults tell a different story. Moore and colleagues ran a biphasic regression analysis in 2014 and found the breakpoint sits much higher, closer to 0.40 grams per kilogram, which lands around 30 to 40 grams per meal for most people. Feed an older adult 20 grams and you're leaving muscle building potential on the table. Feed them 35 and you've crossed the line where the machinery actually turns on. This is anabolic resistance, and the phrase makes it sound like something's broken. It's not. Older muscle isn't damaged goods that can't respond to protein anymore. It just needs a louder signal to get the same response younger muscle gets from a whisper. Same door, heavier lock. You just need a bigger key. That brings up leucine, because leucine is the amino acid that acts like the ignition switch for muscle protein synthesis. For young adults, the working number is 2.5 to 3 grams of leucine per meal. For older adults, it's typically cited at 3 to 4 grams, sometimes higher depending on which paper you're reading. But here's the honest caveat, and it matters. Recent reconsiderations of the leucine threshold model have pushed back on how rigid this number really is. Some 2023 analyses found no clean, universal threshold could even be identified in older adults, And plasma leucine levels didn't reliably predict the size of the muscle protein synthesis response. So leucine is a real signal, it's just not the only variable in the room. Total protein and total essential amino acid content matter just as much as hitting some specific leucine number on a spreadsheet. Treat these thresholds as useful targets, not laws of physics. So, what does this look like on a plate? 4 to 5 protein-rich meals a day, each one crossing the threshold for your age group, spaced 3 to 4 hours apart. That spacing isn't random. Muscle protein synthesis rises after a meal, then falls back down. And eating again too soon inside that refractory period doesn't re-trigger the response the way you'd hope. And this is where the distribution debate comes in, because you'll hear conflicting things depending on which study someone waves at you. Mamro's 2014 trial found that spreading protein evenly across 3 meals, 30 grams each, produced 25% more muscle protein synthesis over 24 hours, compared to a skewed pattern of 10, 15, and 65 grams. That looks like a clean win for even distribution. But then, Kim's 2014 work and a newer 2025 trial from Barnes found no difference at all between even and uneven patterns once total daily protein was matched, and each meal still hit the threshold. So which one's right? Both, actually, once you understand why they disagree. Distribution matters most when it prevents a meal from falling below the threshold. If your skewed pattern still gets every single meal above 20 to 25 grams for a young adult, or 30 to 40 for an older one, the even versus skewed argument mostly disappears. The real crime isn't uneven distribution. It's a breakfast with 6 grams of protein that never had a chance to trigger anything in the first place. So the dosage picture is settled. Hit your daily total, hit your per meal threshold, based on your age, space it out enough to reset the machinery. But there's one more question everyone asks the second they hear these numbers, and it's usually delivered in a slightly panicked tone. Does eating this much protein wreck your kidneys? The consensus answer, based on DeVries's 2018 meta-analysis and a separate 2018 review from Van Elswyk, is no. Not in healthy adults. Not even at intake stretching from 1.8 up to 3.3 grams per kilogram per day, which is well above what almost anyone reading this is actually eating. Here's what's actually happening instead. Yes, GFR goes up. Yes, urea goes up. But that's adaptive hyperfiltration, not damage. Your kidneys are working harder to process more nitrogen, the same way your heart works harder during a run. That's not injury, that's function responding to demand. The OmniHeart trial is a good example. Bumping protein from 15% to 25% of total calories raised, estimated GFR by about 4 milliliters per minute, and after 6 weeks, there wasn't a single disease marker showing up to suggest anything was going wrong. Now, the honest caveat, because a clinical ledger doesn't hide the messy parts. Most of this data covers 6 months or less. Long-term numbers, years and decades, are thinner. One Korean cohort study found faster kidney function decline in the highest protein intake quartile. But another cohort, this one using directly measured GFR instead of estimated, found no association at all, even at intakes up to 3.7 grams per kilogram. So this isn't fully settled science. It's mixed, and healthy skepticism about very long-term, very high intakes is reasonable until more data comes in. There's a second layer to metabolic health beyond kidneys, and it's about timing within the day, not total amount. Cohort data links early day protein intake, meaning a solid breakfast and lunch, to better transitions toward a metabolically healthy phenotype in people carrying obesity. Flip that pattern around, skew most of your protein toward evening meals, and the same cohort data shows worse glycemic patterns. So while total protein rules muscle outcomes, when you eat it seems to carry some weight for metabolic health, specifically. Last piece of this verdict, plant protein. Leucine-matched blends, think pea rice canola or wheat corn pea combinations, go toe-to-toe with whey for muscle protein synthesis in young adults. That's a real finding, not a marketing claim. But single-source plant proteins, plain soy or plain wheat, on their own, underperform in older adults unless they're fortified with extra leucine or the dose gets pushed considerably higher. So the ceiling isn't dangerous. The timing has a smaller but real effect on metabolic markers, and plant protein works fine if you build it correctly. 3 verdicts down. Now it's time to turn all of this into something you can actually do at your next meal. Total daily protein, hit consistently, and per meal thresholds crossed every single time. That beats obsessing over minutes on a clock every time this ledger's been checked.